Hello all, in this video we will solve a transmission line problem related to single stub matching using Smith chart. Let's see the question first. A lossless transmission line with a characteristic impedance of 100 ohms is terminated in an impedance 26 minus j 16 ohms. This load is to be matched to the transmission line by using a short circuited stub. With the help of Smith chart, determine the length of stub and its distance from the load. As you all know that the stub matching problems are solved easily in terms of admittances as they are connected in shunt for the impedance matching. The solution for the problem starts with the calculation of normalized load impedance. In this problem, the normalized load impedance is 0.26 minus j 0.16 that I am writing here for the reference. Let's mark the normalized load impedance of j 0.26 minus j 0.16 on the Smith chart. See, the resistance R value should be 0.26 and reactance X value should be 0.16 and mark the point. Once we mark the normalized load impedance with a scale, join the point with center of the Smith chart, which is matched load point. You can see the scale is being lengthened or adjusted so that we can join the center to the point marked. Extend the line onto the other side. So that it crosses the complete Smith chart. Now indicate the load line with ZL and YL on the other side of the line. Now take the compass, consider the radius from center to the load point. As you can see, the length has been adjusted. And now draw the constant S circle using the compass. You can see the constant S circle is been drawn. This constant S circle cuts the load impedance line on the other side, and the new point is the normalized load admittance. You can see the point has been marked, and since it is admittance, we have to consider the real part as conductance and imaginary part as susceptance. And you can see that the real part is 2.8 and the real part that you can observe is the conductance is 2.8 and the susceptance part is representing 1.7, that you can see it as 1.7. So I am writing here the load admittance is 2.8 plus J 1.7. The objective of impedance matching is normalized input impedance measured from the load should be a purely real value of 1 or normalized input admittance should be equal to a real value 1. Now from the load admittance line, travel towards generator, that is in clockwise direction, and see the point where the constant S circle cuts the R equal to 1 cycle. So this Yn is marked and has a value of 1 real part and the imaginary part as J 1.45, that you can see here. The imaginary part is J 1.45, but this value is below the horizontal line, reference line, so it is minus J 1.45. So Yn, which is obtained by this S cycle crossing the R equal to 1 cycle, it is 1 minus J 1.45. It has the susceptance value now. Now, just to have the points, point P is representing the normalized load impedance, point Q is representing normalized load admittance, and point M is representing the normalized input admittance measured at a distance from the load admittance such that real part of Yn is 1, but it contains also the imaginary part of minus J 1.45. To achieve the impedance matching condition of Yn equal to 1, we need to connect a short circuited stub in shunt at the point where the real part of Yn is 1. The Yn measured from the shorted stub will be purely susceptive, and when connected in shunt will cancel the value of minus J 1.45. Since the susceptance of Yn is minus J 1.45, mark the value of susceptance of short circuited stub at plus 1.45 on the zero resistance circle in the clockwise direction from YSC point, which is marked on the extreme right of the Smith chart. You can see I have marked plus J 1.45, and that is the input impedance measured, J 1.45 for the short circuited stub from the YSC point, which is marked on the extreme right of the Smith chart. That you can see here. This is from YSC. For reference, I am marking here. So this is the point where we observe open circuit ZOC. Obviously, it is YSC, and this point is representing ZSC, and obviously it will be YOC. So always from YSC in the clockwise direction, J plus J 1.45 is marked. Now join the point M and center of the Smith chart with a line. You can see a line has been drawn. Now measure the distance from the load admittance in clockwise direction to the line marked based on Yn value of 1 minus J 1.45, and this distance is Ls as asked in the problem. Now measure the distance from the YSC towards the generator in the clockwise direction till the mark of plus J 1.45. That gives the length of the stub. Once connected, will achieve the objective of impedance matching for the actual transmission line. And it is represented as LT. Here, Ls is the distance from the load admittance in clockwise direction, and LT is the length of the stub. The distances measured are Ls equal to 0.102 times the wavelength from the load line, that is YL, and the length of the stub LT is 0.406 times lambda. Actually, you can see it is being measured from YSC to the point where we have marked plus J 1.45. It is 0.406 times lambda, that is wavelength. So this is the process of solving this single stub matching problem using the Smith chart very easily. Thank you for video.